So having said all of that, there are a number of products typically in any given application where several different model numbers or several different brand manufacturers can be picked. So that's a nice part about having a portfolio of products, not just for humidity and temperature, but others, so that we can, in most cases, share with the customer the benefits, the pluses and the minuses of different technologies, different manufacturers, and of course, different prices in order that we pick the right solution to limit or minimize the excursions in your process. Everything we've talked about, pretty much everything we've talked about, is available on the Industrial Controls Online website. There are a lot of spec sheets. After this webinar, the actual webinar will be posted. We've also got a new catalog. Those of you that are on our mailing list have probably received it. So there is a section in that catalog that actually talks about the different technologies and the different flavors of humidity and temperature, as with many other product lines. And in fact, the new catalog can be viewed either in its traditional form, or you can actually now turn pages in the catalog or use a search engine to get to the right page on the catalog on our website. So I hope that was helpful. If you would like any more information, you can contact me at Industrial Controls. That's my email address, whopler@icdml.com, mobile phone number. And with that, Jen, please open it up to questions.
Okay, thank you, Bill. I'm going to read some of the questions that came through the chat. The first one came through from Tim. Is there a storage life on replacement sensors that are kept as spares?
That's a great question. I think I touched on it briefly, but yes, every humidity sensor that's stored on the shelf, even if it's not in an actual application or being used, does have a change in calibration over time. A very good sensor, as I mentioned, would have less than 1% RH drift per year, but that's a very good sensor. Others will drift more than that. But yes, so you do want to be, if you have a tolerance that you're trying to maintain, it's always a good idea to set up a program where you're swapping out probes, you're putting freshly calibrated probes on the transmitter itself, and then when you need to recalibrate beforehand and then do a swap at 6 months or 12 months or whatever your interval is.
Okay, thank you. We received another question in from Anthony. He asks, we use thin metal film capacitance sensors in our HVAC system in controller areas. Vysela HMD-70Y. Are there special care or cleaning recommendations for these types of sensors?
With any humidity sensor, you know, I'm not familiar with all the manufacturers and if they can handle cleaning or not, but basically you don't want to touch the sensor itself. You would want to make sure the filter is clean, and usually filters are replaceable. If it is saturated, if it's a capacitive sensors, some manufacturers can't handle condensation, but some can. That sounds like that's a Vysela unit. I'm not sure how they handle on condensation, but you do want to make sure it's dried off before going back into service, and by drying off, just by flowing dry air over it. But as far as cleaning, no, it's not recommended that you wipe the sensor down at all. Only really changing the filter elements is the best practice there.
Okay. We also received another question in from Anthony. We do 2 types of calibrations on our HMD-70Ys, a single point calibration with a handheld device and a loop calibration using a 2-temperature, 2-pressure chamber and a digital multimeter. Are the sensors in the HMD-70Y swappable in either case?
Again, I'm not familiar with Vysela's products, so to speak, so I don't know if they are swappable or not. From my understanding of them as a competitor, They do have some swappable probes available, but I don't believe that they are digital. I think if you were to swap those particular probes, then you would need to do a follow-up calibration on that. But again, I'm not too familiar with that procedure.
Okay. Another question in from Anthony. What type of sensors do you recommend for an ETO environment in a sterilization?
Ethylene oxide is tough. It eats away sensors very quickly. It's a very aggressive solvent, and there aren't too many sensors I'm aware of that can hold up. I can only speak really for previous companies I work for. I don't want to mention them and diss them, but they don't hold up more than a couple cycles. Rotronic sensors in general can last 4 or 5 cycles, but then again, they will need to be replaced after that. There's no great solution for that application. It's very difficult because of the aggressive nature of ethylene oxide.
Okay, thank you. Another question in from Liz. She asks, I have 2 different humidity sensors placed together and monitoring the same room. Calibration results are within 2% of each other, but the actual data routinely collected is about 5% different. What causes this?
If I understand the question, the sensors are reading within 2% of each other, but the collected data is different?
Yes, the actual data is about 5% different.
Well, there's probably a few things you want to look at there. Over what time period was the data collected? We mentioned in the slides a bunch of external factors. I know that you said they're side by side, but is there any flow going over the sensors? Is there any HVAC equipment? So once you eliminate the external factors, then you'd have to look at perhaps the electronics. And I don't know if collected data means from an analog source on the chart recorder. There may be some error there because, again, if the 2 sensors are calibrated and within 2% of each other, I don't understand how the collected data would be different unless there was some problem with the perhaps the digital to analog converter or something with the electronics. So that might be an electronics issue there.
Okay. Another question in from Bob. He asks, are there standard temperature and humidity ranges for humidity transmitters?
When you're ordering a humidity device, most manufacturers do have standard ranges, but some of the new digital technology allows for adjusting those ranges in the field, either with a handheld device or with software. I would suggest that most manufacturers would give you a range that you request before shipment, but if you're in the field and you have several of these, I know with Rotronic it's a good idea. We have a software and service cable that plugs into most all of our devices for programming, and you can adjust the output ranges on in most cases. So if you needed a special temperature or a relative humidity range or even a dew point output, that can all be done in the field with software and a cable.
Okay, thank you. We actually just received another question in from Amar. They ask, what is the average cost for the handheld devices like Rotronic, Hygro, HP23, and what is the average cost for the probes?
A standard probe, which can handle 100 degrees Celsius from Rotronic, is $345. And then the HP23 by itself is approximately $600. So you're looking at just under $1,000 for a 1% accurate unit that can data log.
Okay. Another question in from Thomas. He asks, how do you ensure an unbroken calibration chain for calibration standards to a national or international body?
I'm sorry, Jennifer, could you repeat the question?
Sure. How do you ensure an unbroken calibration chain for calibration standards to a national or international body?
Okay. Well, for Rotronic, we have equipment that is traceable back to NIST. NIST is the U.S. government standards for measurements and calibration, and they basically what we have is a chilled mirror standard. This standard at Rotronic is sent back for yearly certification down to NIST. NIST will test this against their standards and give it basically their seal of approval and a NIST traceable number. That number is good for the year. This NIST traceable device is sent back to Rotronic. We have 2 of them, so we're never down on a rotating basis. And then this NIST calibration device monitors our entire calibration chamber or flow facility, if you will. So every probe that is calibrated has the ability to get a NIST traceable calibration certificate. And on that certificate, those numbers tracing back to NIST can be found. Now, there's also international guidelines like ILAC, the international guidelines, which NIST is a part of, use the same guidelines for good practices and calibrations. It's more of an international standard, which several smaller standards like NIST follow. So there is a worldwide international body that governs calibrations as well. That NIST is a member of. I hope that helps.